Okay, it's opening up. Should see it shortly. Okay, yeah. So let me make it a little bigger. Yeah, it should get bigger shortly. All right, guys. So remember, you have the booklet, but for those of you who can't use the booklet right now, then just try to use your screen. All right, so the first thing I want to talk to us about is, hold on, let me put this. Right, so the first thing we want to talk about, right, is Pythagoras theorem, right, and this is only for right angled triangles. So why am I saying this? Because when you have the questions and there are different things to do. Yeah, hold on, let me see if I sent it to you guys. I believe I did. Hold on, let me just see. Oh, hold on, guys. Let me send it quickly so that you guys can have it. My apologies. You are right. I'm going to send it to you guys on WhatsApp for those persons who can get access to it. So that maybe you can look through. Okay, my bad. You are correct. My apologies. Yeah. Okay. So as I said, you want to know what you should use for which triangle, and I'm saying that when we have the right angle triangle, you're going to be thinking Pythagoras theorem or the trig ratios. Right? So two things, and that's what we're going to cover today. So only for right angle triangles. Now, you want to note that Pythagoras' theorem says that the hypotenuse squared is equal to the sum of the other two sides squared. Right? So we want to remember that the hypotenuse, some person says this one. A good way to mark it is that it's always across from the right angle. Right, so this would be your hypotenuse. And then doesn't matter which side you put first, I'm gonna call this side 1 and call this side 2. Now this formula, not on the formula sheet, which means you need to make note of that as something to remember. Right, so I think in fact, January 2019 might be a good way to bring this out. So for January 2019, hold on, some persons coming. All right, so I'm gonna focus on January 2019. Let's look at it. Right, it says the diagram below shows a right angle triangle with sides A, B, and C. It says using a diagram, express C in terms of A. Yeah, that's fine. Right? Express C in terms of A and B. Now, since it's a right angle triangle, and it's asking me to talk about all of the sides, I'm saying this is where you would know that they're asking you to use Pythagoras Theorem. So this is across from the right angle, so we know that this is the hypotenuse. And then this would be the other two sides, right? So we can call this side 1, side 2. So coming back over here, right, according to that, so this is 1A, right? It would be that C squared is equal to, and I mean, I can put A or the B, it doesn't matter if you want to put the A or the B in front. So maybe let's call this, so that it follows it. Right, so we have that C squared is equal to A squared plus B squared. Right, so when they ask you to express C in terms of A and B, that's what we were supposed to do. To say the hypotenuse squared is equal to A squared plus B squared. Talk to me, is everybody seeing that? Can I get some yeses, some no's? Let's go through it part by part. Is everybody with me for the first one? If there is a no on the table, now is your time to declare. Right, if there are any no's on the table, let me know now. Right, guys, remember that typing yes in the chat is a good way to engage, ensure that you're not sleeping and stuff like that. Right, so no sleeping, no scrolling. All right, so finish writing that off. So this, the top part was in general, and then we actually use it for the question. Now the second part says they want us to write in terms of A, B, and C, an expression for sine theta plus cos theta. So this is where the whole trig ratios is going to come in. Let me just prepare it here since I'm going to erase. Okay. Then now the second question says to write sine theta plus cos theta. So the next thing we want to talk about, right? So we spoke about Pythagoras theorem. We want to speak about the trig ratios, right? So we're supposed to, almost sure every school uses SOHCAHTOA. What they say SOHCAHTOA means, that's another thing, but pretty sure everybody uses this. So what does this acronym mean, right? So the S is for sine, and it says the sine of the angle, whatever the angle is, sometimes the angle is X, in this case it's theta. The sine of the angle is the opposite side over the hypotenuse side. And we're going to talk about how do you know what is opposite, how do you know what's adjacent, and I mean, I've already spoken about the hypotenuse. Then for the C, right, this is saying that cos theta, if you notice the A, so I put it first over the hypotenuse. So it's supposed to help you to remember what to do. Right, and then tan theta, let's go green. Right, would be opposite over adjacent. We always want to remember it's always the sine, cos, and tan of the angle, right? So it's always sine theta. If it's cos x, whatever it is, this portion is the angle, right? So you never put the measurement of a side there. That's always the angle for whatever question is being done. So I do want to talk to you about how you identify the opposite. The hypotenuse. All right, that's all. All right, so let's look at how to identify the different sides. So let's go back to that. All right, so the hypotenuse, as I said, always across from the right angle. And you always label it first. That way you don't mess up the other two, right? So if you label your hypotenuse first, yeah, I'll go over the ratio shortly, right? So you want to label the hypotenuse first at all times. So it doesn't matter how the triangle is flipped, right? We label it as the hypotenuse being across from the right angle each time. Right, then it also depends on where the angle is. So let me put right. So after you label the hypotenuse, that leaves only two sides, right? That's the beauty of the triangle. You'll always only have two sides left. So that's why I tell you to label the hypotenuse first, because then it allows for your chances of messing up the other two to be reduced significantly. So the side that you call the opposite, right, will be across from the unknown angle. Right, and the adjacent will be beside the unknown angle. Right, so obviously, in all cases, one will be close, one will be far. So this has to be the adjacent, this has to be the opposite. This one is close, so this has to be the adjacent, this has to be the opposite. This is closer, so this is the adjacent, this is the opposite. This is closer, so this is the adjacent, that is the opposite. So what we're looking at is how to identify which one is opposite, which one is hypotenuse, which one is adjacent. Extremely important, because if you don't label this correctly, then you're going to use the wrong ratio. All right, so it's extremely important that you know how to label the sides. Now for those persons who came in late, I'll try to repeat some of the information for you. But essentially, we're on trigonometry, and I'm saying that you have to know when you're using the trig ratio, which is over this side, it speaks about opposite, right? So the O is for opposite, the A is for adjacent, and the H, right, is for the hypotenuse. So you have to know how to label those signs. So I'm saying that the hypotenuse, you want to label it first, and it's always the side across from the right angle. Then you have two sides left. One will be extremely close, one will be far. Okay, so this is a bit of the teaching. So take this down. If there are any questions about the sides, let me know, and then I'm going to go back to the trig ratios. So for those persons who are finished, try to label the given triangle for the question. So label which side is the hypotenuse, which side is opposite, which side is adjacent. Do that in the meantime. Okay, so we're going back to the acronym. If anybody was still writing, just let me know. So we're going back to the acronym, which is SOFATOR, right? So I'm saying that the S represents sine, the C represents cos, and the T represents tan. Right? So I'm saying that sine means you should put the length of the opposite side over the length of the hypotenuse. Cos means that you should put the length of the adjacent side over the length of the hypotenuse. And the tan means the length of the opposite over the length of the adjacent. So let's label what we have over here. So across from the right angle, we know that that is the hypotenuse. And then that leaves two sides, right? One close, one far. So this is the adjacent and this is the opposite. All right. So for this question, it says write an expression for sine theta plus cos theta. So we have to take a stop. What is sine theta? Sine theta is what? Opposite. So let me put it down here for those persons who don't know it yet. Right? Sine theta is opposite over hypotenuse. Again, guys, this is not come on the formula sheet, so you do need to know these things. So sine theta, the opposite is A, and the hypotenuse is C. So sine theta is A over C. And at the same time, cos theta is the adjacent over the hypotenuse. So this is telling us that cos theta is B over C. So if I'm supposed to put it together, sin theta plus cos theta is really A over C plus B over C. And I mean, if you wanted to, since it's a fraction, they both have the same denominator, you can go ahead and add the numerators. So as a bonus, so that you're able to see it, if I have 3 over 4 plus 5 over 4, I keep my denominator and I add the numerators. So that would be your answer. But again, you'd have to know, how do I figure out what is sin theta? How do I know what is cos theta? And I'm saying that you first have to be able to label the sides correctly. Because if you mix up the opposite and the adjacent, which is what most students do, then you'll put the wrong letters. Okay, so before we go to the last part, can I get some yeses, some no's? Talk to me. Let me know what part you need me to go over, what's not clear. All right, if you're okay, give me a yes. If you're not okay, now is your time to declare. Okay, so all the persons who responded have given me yeses. So I'm going to give a minute more and then I'm going to work part 3. Okay, maybe not a minute, but a couple seconds. All right, so now we're being told, show that right, that sin theta squared plus cos theta squared is equal to 1. So very important. This word show means that they're giving you the answer, which means you cannot go ahead and do it and get another answer. The word show means this is the answer. They're telling you this is the answer. They just want you to show them that you agree with them that it is the answer. Okay, so they say, well, if sin theta, what do we find sin theta to be? Sin theta was A over C. So sin theta squared is A over C squared. Right? Cos theta was B over C. So cos theta squared is B over C squared. Now, a rule of indices you want to remember, so this is as a bonus, right? If you have a a fraction raised to some power, you apply the power to the numerator and the denominator. All right, so you apply power to the numerator and the denominator. So what do I mean by that? I'm saying that this sine theta squared, which was a over c squared, is going to become a squared over c squared. All right, so we're going to finish up, but take off this page. So what I did, I know sine theta, so sine theta squared, I simply just put a squared around what we already knew. This part, we found from the part B of the section. Okay, so I'll come back to this page and we just finish. So then cos theta squared, which was b over c squared, is going to be b squared over c squared. So since they're asking us for sine theta squared plus cos theta squared, this is really what? A squared over c squared plus b squared over c squared. And if we have a fraction with the same denominator, we go ahead, we keep the denominator and we add the numerators. I'm gonna go over it, but let me just finish so that I don't break the momentum for those who are following. So look at it. From part IA, we said that c squared is equal to what? A squared plus b squared. That's what we got for part A. So I can say that this is c squared over c squared, and any number or letter divided by itself is 1. Right? Which is what they asked us to prove. They asked us to show that it is equal to 1. So I'm going to come back here, but I'm going back to this page. So was there anybody having any issues with this page? So before we go over to the next page, was there anybody having issues with this page? Yeah, so you have to say no, it's just more so if there are persons who did. Okay. Anybody still writing anything from this page? So only those who are giving me a yes, yes, if you're still writing, indicate. If not, I'm going to turn over. Okay. All right. So you guys are on this page then. So are there any issues with this page? Okay. If not, finish writing. And then I'm going to go to May 2005. And we talk a little bit about how to work this. Okay, I want to switch the page. Everybody's writing. All right. So we are going to May 2005. So it says that a vertical stick. So we want to point out some stuff. So vertical is up down because most students mix up vertical and horizontal. All right, and you want to remember that horizontal means across. Well, not means, but it's the one that goes across. All right. All right, so they say the vertical stick of height 1.8. So instead of saying stick, I'm going to say person, just so that you guys can maybe envision it a little better. All right, so let's say 1.8 meters. And it says it cast a shadow of length 2 centimeters. So imagine on the floor, you look on the floor, right? And you see in your shadow. So it's a stick, but I'm trying to use a person just because you might can envision you standing up and I see your shadow on the floor. Right? On the horizontal. So if you notice, this is talking about the vertical. This is about the horizontal. They said calculate to the nearest degree. What does that even mean? What does the nearest degree mean? It means no decimal. So if you say to the nearest whole number, to the nearest dollar, stuff like that, usually it means no decimal. Right? The angle of elevation of the sun. Right? So with these questions, as you can see, any angle of elevation, depression question will still turn into a right angle triangle. Right? So when you see stuff about angle of elevation, angle of depression, it is always a right angled triangle. Now I do want to talk to you a bit about angle of elevation versus angle of depression. Right, but we want to know that the angle of elevation right is always from the horizontal up. So for example, if you're looking at this diagram, right, you may be inclined to put it here or here. There's only two other angles. The angle has to be one out of the two. But I'm saying it can't be the one up the top because the one up the top is not coming from a horizontal. So what do I mean by that? The horizontal is here. And then the angle goes up. So this is the angle of elevation. So you always want to remember the angle of elevation is always from the horizontal going up. Right? If I was supposed to do it here, this is from the slant down or the vertical up. That's not the definition. It's from the horizontal up. Okay, so those who need to take notes, take notes. All right, so for example, if you have All right, so if we have these two, this is the horizontal, so depending on how it's drawn, it's either from the horizontal up or the horizontal up, right? So it's always one of these two. And I'm saying that in this case, this is the angle of elevation. So when we start to do those questions, I'll talk about depression. I don't really want to stray too much. All right, so we're going to talk. So I'm just going to call it X. All right, and this is 2 meters. This is 1.8 meters. So we're asking for the angle. Right? So let's label the sides first. So step 1, you want to label the sides O, A, and H. All right, so this is the hypotenuse. And we have our 2 sides. This is the adjacent. This is the opposite. Then step 2, decide what 2 sides to use. Does it make sense I use the hypotenuse because I don't know it? So I'm going to use the adjacent and the opposite. Then step 3, choose the ratio that has those 2 sides. All right, so sine has opposite and adjacent. Cos has adjacent and hypotenuse, and tan has opposite and adjacent. So we know we are going to use tan. So again, for a question like this, you've been asked to find the angle. You want to label your opposite, adjacent, hypotenuse. That's always first. Step 2, decide what 2 sides you're going to use. I'm saying in this case, I wouldn't use the hypotenuse because I don't know it. So why not just use the 2 sides that I do know? I mean, you could use Pythagoras Theorem and find the hypotenuse, but again, unnecessary work when you are in a timed exam. So I'm saying you always have information about 2 sides, use those 2 sides. Then you're going to choose your ratio based on the 2 sides that you have. So before we finish calculating, is everybody with me up to here? Give me a yes in the chat if you're with me up to here. If it's a no, now is the time to declare. Okay, I have only about 10 answers. A lot more people on the class. So guys, I have to just go with those who are answering, and the people who are answering, they're saying they're okay. So please do not take it that if I'm moving on, it means that I'm ignoring you. It means I'm giving you the opportunity to say you're not okay, but you're not taking advantage of it. All right, so in this case, we're going to say that tan x, right, since tan is the angle, is what? The opposite over the adjacent. So tan x, what's the opposite? The opposite is 1.8 And the adjacent is 2. I do hope everybody has their calculators. Trigonometry is that topic that you must have your calculators, and not just any calculator, but the calculator that you're going to use in the exam. That means no computer calculators, no phone calculators, the calculator that you're going to use in the exam. Okay, so because I want the x by itself, there's something I am going to have to do to get rid of that tan. And to get rid of the tan, you have to tan inverse the opposite side. So for those who didn't know, now you know. So as a bonus, right, if I have that sine x is equal to a half, if I want to get rid of the sine, I have to sine inverse the other side. And I'm going to show you how to put that in a calculator, right? If I have cos x is equal to a half, to get rid of cos, I have to cos inverse the other side. So in terms of for a Casio, you should be seeing sine, cos, and tan. But above tan, I'm not sure how the other ones work, but it's usually pretty similar, right? So above tan, I'm seeing tan inverse in yellow. So I'm going to press shift. And why am I pressing shift? So the shift on your calculator, if you notice, it's in yellow. So when you press shift, it activates everything that is in yellow in your calculator. So when you press shift and then tan, what you should see appear is tan inverse. That's what you should see on your calculator. Then I would put a bracket and put 1.8 divided by 2, close bracket. Right, so I put tan inverse, open bracket, 1.8 divided by 2. And what we should be getting is 41.987. But of course, I said to the nearest degree, so we'll soon talk about that. So everybody try to get that in your calculator. Guys, do not wait until the day of the exam to figure out how your calculator works. Try it from now. Right, so that's how you use that function on your calculator. If you put in sine inverse of a half, you can test it out to make sure that you know how to use it. Should be getting 30. If you put in cos inverse of a half, you should be getting 60. All right, so just giving you 3 different functions that you can test it out. So again, it's shift, tan, and then what you want. And because I said to the nearest degree, no, so do not use, I mean, if you have to use the Google calculator for today, sure, but I'm telling you guys, do not use it. You will go into your exam and not know what to do because you cannot carry the Google calculator into the exam. Right? And it would be 42 degrees. So I'm going to talk about the rounding shortly. Actually, let me do it now. All right, so we have 41.987. So the nearest degree means no decimal. So I draw my line and I look to the right. If it is 5 or more, you add 1. So that's why I have 42. If, for example, as a bonus, suppose it was 41.2, right? I draw my line, look to the right. It's not 5 or more, so it stays as 41. Suppose it's 41.5. I look to the right, it can be 5. So if it's 5 or more, you add 1. Right? So 5 or more, you round up. Yeah, sure. All right, so while I wait on explaining to other persons, those who are finished, try May 2021. All right, but anybody else needs me to go to a specific page, let me know. For the others, let me give them a moment to write off, and we'll go to May 2021. Okay. Anybody taking off anything else? Okay, so they give us a triangle, and they say the size of angle PRQ. Now for this one, we want to remember that angles in a triangle sum to 180 degrees. All right, so it wouldn't make sense to use one of the ratios because we don't have two sides. So we just start off saying, okay, let's go with something else. So what I'm saying, guys, is that the 62 plus the 90, because we know the right angle symbol means 90, plus what we have over here, all three of those should add to 180 degrees. So 180 degrees should be 62 plus 90 plus what we're looking for. All right, so 180 degrees is 152 degrees plus x. So 152, which is added. When we take it across, we subtract. Yeah, so it should be 28. All right, so angle PRQ is equal to 28. Yeah, have to subtract. Okay. Then now, for the next one, it says they want the length of RQ right? So RQ is here. So they want the length of RQ. So again, guys, when you see stuff like this, you want to be thinking either Pythagoras theorem or the trig ratios. We wouldn't say Pythagoras theorem because we don't know these two sides. We have to do Pythagoras theorem, we need at least two sides. So maybe that's something we can make a note of. All right, so to use Pythag, we need to know two sides. So that leaves us with just the ratios. So go ahead, label which one is the hypotenuse, which one is the opposite, which one is the adjacent, and decide which one you're going to use. I want you to try it before I do it. Right, so what do we have working with? This is the hypotenuse. This is the opposite. That's the adjacent. Right, so across from the right angle is the hypotenuse. That then leaves two sides, which is the adjacent and the opposite. You always then want to think about, okay, what two sides am I working with? I would want to choose the hypotenuse since I know it. And they've asked me about RQ. So those are the two sides I'm going to focus on. I don't know anything about the adjacent, so that's not helping me. So I know the hypotenuse and they've asked me about RQ. So we're going with hypotenuse and opposite. So no, it wouldn't be tan. We would use sine. Is everybody seeing that we would use sine? Is everybody seeing that we would use sine? Okay, I have one no. What about the others? Are there any more no's? Okay, for the person who said no, did you label the triangle the way that I did? So meaning is your hypotenuse opposite and adjacent where my own is? Are you agreeing that they're in the right place or did you have it differently? Yes, meaning same. Okay, so think about it. Yeah. So I only put the X there because that's what I'm looking for. Right? Okay. So I'm saying to you, us using the 11, doesn't that make sense to actually know it? It doesn't make sense to use the adjacent because we don't know it. So if I can only use two sides, think about it this way. If I use the adjacent and the opposite, that leaves me with two things that I don't know because I don't know the adjacent and I don't know the opposite. That's not going to help me. So instead, the fact that they've given me the 11, right? I'm going to use the hypotenuse and the opposite, which is sine. Right? So we say that sine 62 is equal to RQ or X over 11, right? So sine 62 is equal to the opposite over the hypotenuse. So sine 62 is equal to RQ over 11. So we use 62 because that's the angle. So remember I said it's always sine, cos, and tan of the angle. So whatever comes after is the angle. And you can't use the 90 degrees. So it has to be one of the other. Okay, then we need to solve for RQ. So the 11, which is divided, when I take it across, I am going to multiply. And you put that in your calculator, you press 11, the times button, sine 62, so no shift, just the sine and the 62. And you should be getting 9.7. So put it in your calculator and let me know if you're getting it. So we only use the inverse when we're finding angles. So the only time that you use the inverse is if you're finding angles. So you'll never be finding the side and using the inverse function. The inverse function is only for when we are finding angles. Right? So we only use the inverse functions to find angles. Okay, are there any questions for everyone else? We're going to look at 2012. Guys, just focus. It's an hour and a half. Don't scroll. Don't go on TikTok. Don't be listening to other stuff. Don't be staring outside. Just focus for your hour and a half. Do your little practice and you get it over with. Okay? It's extremely important that you make use of the time. And every single marathon is the same 6 persons that talk to me every single time. Okay, so for May 2012 now, So it says the diagram below, not drawn to scale, shows the journey of a ship which started at P. Right, so we have more little ship, one more like a boat. Right, so the first thing we need to know is, right, that this is north, this is south, that's west, that's east. So the first thing is that you have to know where's north, where's south, where's west, where's east. That's the first thing. So they're saying I can sail 15 kilometers due south to Q, and then a further 20 kilometers to point R. They said copy the diagram, label it to show QR, and then the distances. So the first thing they told us is that we did what? 15 kilometers due south to Q. So based on this, we know that south means you're going down. So this is the 15 kilometers. And he lands at Q. And then now he goes a further. So if you notice, it didn't say he went back to P, then went to Q. It says he went further. So he's already at Q. And then he went a further 20 kilometers west to R, which therefore means he went west 20 kilometers and ended up at R. All right, so that would be your 2 marks for the first part. They then want you to calculate the shortest distance of the ship from the port, which is PR. So they're calling this distance, right? PR, they want to know what is that distance. And your hint is to use Pythagoras theorem, because what did I say? We can use Pythagoras theorem once we have two sides. It's a right angle triangle that's formed. So we can use Pythagoras theorem. Right, giving the person a moment to write. If anybody has any questions about the first one, please let me know. All right. So, joining this, right? This would be the hypotenuse. Right, and these would be the sides. So we know that this is the 15 kilometers, this is the 20 kilometers. So using Pythagoras theorem, right, we're saying that P R squared is equal to 20 squared plus 15 squared. Right, so the hypotenuse squared is equal to the sum of the sides being squared. So PR squared is equal to 400 plus 225, which means that PR squared is equal to 625. And for those who don't know, so just like how to get rid of sign, somebody said question mark. What's a question mark for? Right, so just like how we did the sign inverse to get rid of the sign, if you want to get rid of the square, you have to square root the opposite side. Right, so whenever you want to get rid of a square, you square root. And then you will get 25. Yes, it is 25. Good job. Yeah, have to remember the square part. All right, then we're going to focus on this last one. Are there any questions about the 25? Please let me know. Is there any questions? Now is your time to ask. Okay, perfect. Okay, so we're going back. Okay, that's not really geometry today. All right, so we have R, we have Q, we have P. We said this is 15, this is 25, this is 20, and they're asking us for angle. So this is another point we can make. All right, so when they say angle QPR, all right, what they're saying is that the angle is at P, right? So they're saying the angle at P in between Q and R, right? So sometimes persons end up labeling these things incorrectly. So I'm saying it's the angle, right, at P in between Q and R. So this is the angle that they want. Now, because you have all the sides, okay, well, now you know. So yes, the opposite of squared is square root, and the opposite of square root is square. Do I have any space for that? Right, so for example, just as a bonus, suppose I have the square root of x is equal to 4. In order to get rid of the square root, I have to square the opposite side. Okay, so the opposite of square is square root, and the opposite of the square root is the square. So for all those who didn't know, we know now. Right, so I'm saying that when they say angle QPR, I want you to be able to identify where the angle is, and it's the angle at P that is in between Q and R. So I'm saying that you can actually use any of the ratios that you want. right? It's completely up to you. So you can't use any side. The side you use depends on what ratio you want to use, but because you know all the sides, it's completely up to you. What this is the opposite, this is the adjacent. So what do I mean by that? So for those who want to use sine, which is opposite over hypotenuse, those persons, right, are going to use 20 over 25. Those persons who want to use cos, right, they are going to use 15 over 25. And those persons who want to use tan, so in the other cases, we only had two sides, so there was no options. But in this one, because we know everything, we can use any of them. Right? And what did I say? Whenever we are finding angles, we always use the inverse. So x is equal to the sine inverse of 20 over 25, or the cos inverse of 15 over 25, or the tan inverse of 20 over 15. All of them are going to give the same answer. And yes, you should be getting 53.1. Or 53, depending on how your calculator was rounding. But it doesn't matter which one you use, all of them should be giving you 53. So anyone not clear, let me know. Everybody else, move on to 2016. Now guys, remember that we started 15 minutes late, so we're getting back that time. So if there are any questions about the previous one that I have on the board now, talk to me. If you're already finished, go ahead and try January 2016. All right, no questions, so we're gonna go ahead. All right, so they've given us the information and they're asking us for the length of RS. Now we're seeing a right angle triangle, so we know immediately we want to be thinking about stuff like Pythagoras Theorem or the trig ratios. Now, some of you might want to think first about that triangle, right? However, if we use that triangle as is, right, I would know that this is 11.2. I would know that this is RS, but I don't know anything about any angle. So they're not telling me anything about angle other than the fact that there's a right angle. And they're not telling me anything about the side. So I'm saying, okay, maybe trig ratios is not the way to go. So instead, what we should be thinking about is, okay, that leaves me with Pythagoras theorem. So how does that leave us? How does Pythagoras theorem help us in this case? So if we can look at the big triangle instead, right? I would be able to find the length of all of down here, which is RT. Right, so essentially what I have right, so I'm looking at the big triangle. I have 11.2, I have 14.8. And what I want us to find is all of down here using Pythagoras theorem. So practice, guys. Right, what is it? Hypotenuse squared is equal to the sum of the sides squared. So 14.8 squared is equal to RT squared plus 11.2 squared. So 14.8 squared is 219.04. And 11.2 squared is 125.44. So this which is added, when we take it across, we will subtract. All right, which leaves us with 93.6 is equal to RT squared. And what did I say? To get rid of this square, the square root. So I will have to find the square root of 93.6 to find RT. And I can tell you that is going to give us 9.67 or 9.7 since everything is there. So all of this is 9.7. Well, I mean, you could round it to 10, but since everything is to one decimal place, I would probably keep it to one decimal place. Right, so it usually try not to round too much. I mean, it's different if they tell you like to the nearest. So that question, the reason we had rounded up is because they told us to the nearest degree. Right, but other than that, try to follow what is happening. So if you notice it has one decimal place, I will probably keep it. So that whole bottom part is 9.7. Can I get a yes in the chat? Is everybody seeing that that whole lower piece is 9.7? For the person who said he calculated saying, you might have to take a picture and send it to me on WhatsApp for me to see what's happening. Right? But the idea, guys, if the full thing is 9.7 and you know that that part is 6, right? then this portion must be what is left over. Right? And so our S is simply 9.7 minus 6, which is 3.7. Okay. So the last question we're going to do for today, rather, sorry. What was I saying? Oh, I was saying send me a picture of your calculator for me to help you figure out what's happening. Because I'm not sure what it's saying, so you probably have to send it to me for me to see. Okay, yeah. So then now this says angle RTW is asking you for the angle that is at T. Right, so it's the angle that is at T that is in between the R and the W. So if I could draw it over here, right? You know that this is 9.7. We know that this is 11.2. And they're asking you for X. So you need to go ahead, label which one is hypotenuse, opposite, adjacent, decide what you're using, and then you go ahead and you find it. Right, so across from the right angle, that's the hypotenuse. That leaves two sides. One across, one close. So the one close is the adjacent, the one across is the opposite. And what do we have? Well, again, you actually have even this one, so it's completely up to you what you want to use. Right, because this is 14.8. So again, you could use any of the ratios. All right, so for those using sine, right, which is opposite over hypotenuse, you are supposed to use 11.2 over 14.8. For those persons using cos, you are supposed to use 9.7 over 14.8. Those persons using tan, all right, you're supposed to use 11.2 over 9.7. So it just depends on which one you are using. Okay, so just because I think you guys are probably messing up some stuff. All right, so we said that sine x is 11.2 over 14.8. We said that cos x is 9.7 over 14.8. So we said that tan x is 11.2 over 9.7. So to get rid of the sine, the cos, and the tan, we're gonna have to use the inverse. So x is equal to the sine inverse of 11.2 over 14.8. Yeah, which should be giving you 49.1. Or it's the cos inverse of 9.7 over 14.8, which is going to give you, when I do it, I get 49.0. Yeah, but that's the same. So you should be getting 49 point something for sure. Right? Or it is the tan inverse of 11.2 over 9.7. So this one also gives me 49.1. All right, let me look at the comments. You rounded up before. Yes, guys, be careful with rounding. Yeah, so you have to do the inverse. So guys, if you're going to round during the answer, always round. Right, you round to 3 or 4 decimal places. Right, so suppose I have sine x is equal to 11.2 over 14.8, but I don't want to have that. So let's say we have 11.2 divided by 14.8. I'm saying I would put 0.7568. So when I'm doing the inverse, I have at least 4 decimal places. Yeah, and then you get 49.2. So just be careful with the rounding. Yes, guys, please do not mix up the SOHCAHTOA. It is the foundation of these type of questions. If you mess it up, you mess up the entire question. All right, guys, so that's what we're focusing on for today. On Wednesday, we're still continuing with the trig. We're going to do the rest of the booklet, which is, I saved one of the questions so that if anybody wasn't here, they'll catch a piece of it. And then we're going to focus on angles of elevation and depression, right? That's what we're going to focus on. So we're going to do that on Wednesday. So once you're finished writing, you are free to go.